Good morning, revolutionaries. How are you doing this morning? My name is Ayon, and I'm going to talk about the ubiquitous role of Solr as a database's not so evil twin. Search engine, Lucene, Solr. When I say those words, what pops up into your mind? Most likely the problem that you're working every day at your workplace or school, and they probably include one or more of these areas: internet and internet search. Relevance, look at that. WoW represents World of Warcraft in an e-commerce world. On a Google website, it would represent something completely different. Search suggestions, faceting. I am pretty sure I don't have to explain any of this to any of you because you're all in this area, and over the course of sessions yesterday and today, you'll learn more about these. Recommendation systems, serving the recommendations, time series analysis, log search, geosearch, geospatial search, analytics. And in my experience, in most commercial settings, I've seen a whole team of people, or very smart men and women, working in each of these areas. So each of these areas are very deep. They're very powerful ways to use a search engine. But today, I'm going to challenge you to think about it in a very different way, a very different use of a search engine. So today we'll learn how to scale any data infrastructure with the help of a search engine like Apache Solr. We'll also learn how to build a high-performance and highly available data platform for internal and external users alike. And we'll learn about Walmart's commitment to open source. A little bit about me. I am a team lead at the Data Foundation team at Platform and WalmartLabs. Walmart is the largest private employer in the world, and also the largest retailer, as you all know. Prior to Walmart, I did work at a couple of startups, so I know the other side and how it is to grow a business and what are the challenges. And before that, I spent almost 6 years at the largest e-commerce company, largest auction company in the world, doing search applications, recommendation systems, and Hadoop-based analytics. I'm also a manuscript reviewer for Manning Publications for a while, and I helped shape the contents of very popular books, Hadoop in Practice and Big Data, among others. About Walmart. We have over 11,000 stores worldwide in 27 countries. We have 11 e-commerce sites across the world. Over 250 million customers weekly in stores and online. Obviously, that means millions of database transactions. By that, I mean actual database commits happening on a database per day across all the checkout counters and e-commerce, everything. And add on to that various different sales and holidays and massive volume shifts. That requires us to serve things at grossly very different scales with very short notice. So what does this mean? It means for us that we have to serve data quickly, repeatedly, and relentlessly. So let's start with a story that is many of us are very familiar with in both businesses big and small. It's titled Growing Pains. It starts up so simple. There's a great idea that I want to implement and get it out there, and we pick up LAMP as an example. Now there are various different stacks, but LAMP is a very tried and tested, quick way to get something up and running. Linux, Apache, Tomcat, MySQL, PHP, or Python, whatever So it starts up so simple: a database, an application server, and front end. It's all working. At this point, as a CTO or leader of the team that is responsible for delivery of this project, it's very, very difficult to figure out whether you want to use tried and tested RDBMS monolithic, or you want to go for a new technology, distributed database, sharded database. It's very difficult to make that decision. It requires a lot of effort. And in a build and pivot startup world, that time is of essence. So you just have to get it out. Once you get it out, it turns out your idea is really great, and you want to find out what's happening in your business, and you fire a bunch of analytics queries on the database. That's the fastest thing to do, and just get the numbers. We need to check what's happening. Two things that are happening here. One is in the OLTP database, the same data is being presented over and over, and the data model has been nicely normalized, and each serving becomes a 5-table joins, and joins are not fun for the database, trust me. And for analytics queries, it can become a 16-table joins. Insane. And we create, just for ease of use purposes internally, we create a dashboard against the source of truth database. Bad idea, but it just has to be done because. So the application or the app or whatever it is that you built, it's really successful, and we add more servers to serve that traffic, but everything is still going to the same database. We add some relief in the front end by adding some in-memory database on the servers, in-memory like memcached, or maybe a cache cluster on the side. It does give a little bit of relief. And the database guys are hard at work in the back end to tune it, to make the things right, and add a bunch of more column indexes to make the queries go faster, but that slows down the writes. And then what happens? It's even more successful, and now analytics, there's more questions being raised at the board meetings or higher up, wherever the rooms are. So we fire more queries to find out exactly what's happening up to the minute or up to the last 5 minutes. And the OLTP database always has the up to the second microsecond data because it's always immediately consistent. So it's a very lucrative place to get your data. And yeah, database is not happy at this point. Actually, the red line is not just from the analytics, but it's also the red lines are from the application servers over there. Scale up in a hurry. The least risky thing to do is actually just scale up the hardware, buy a bigger database box, and because that requires almost no change to the application code, the analytics, all the use cases it's serving. So this gets quickly expensive. It becomes exponentially expensive, where after a certain point, you'll pay an order of magnitude higher amount of money for a linear increase in performance. So how do we get out of this? It's where do we go from here? Let's relieve the pressure. What we have found, luckily, is that internet users, and actually we have found with a lot of analysis of data, that internet users are very forgiving with latency and accuracy for a massive number of use cases. Almost 70 to 80% of the load can be totally not immediately consistent. So they show us, they tell us that show me an item page, or show me some data that gives me a little bit outdated description. A couple of words are different. Maybe a little bit outdated picture. Users will talk about that in the forum or the reviews that, hey, the picture is wrong, and the backend guys will fix it later. But they're forgiving. But you prevent the user from not being able to check out that thing that they want to buy. They'll not forgive you. They'll jump onto the next site with a click and go away for a very long time. If not, that's the one thing that we don't want as a business. So that's very good, 70 to 80%, and we can address that with slightly eventually consistent, near real time, and then those analytics guy over there, they can take a little bit more eventual consistency. So what do? We offload the queries to a search engine. We offload recurring reads to a cache. We offload analytics to an OLAP database, data store. And then, when need be, actually the first three relieve so much pressure. You can delay your sharded database, distributed database for a little bit. I know a lot of us here are selling sharded distributed databases, but it comes with this complexity. So it does come with a complexity, and we have built library and a package of libraries around it to hide the complexity, and it is worth it. The inspiration, the community. We saw that there is Lucene-based search engines are being integrated everywhere. And I don't have to tell you what this means, because yesterday and today and over the internet, we know Lucene, Solr's integration with React, Cassandra, Mongo, Redis, Hadoop, Spark, all happening, and Elasticsearch, Couchbase, all of those. There are probably much more integrations that I either don't know about or I didn't put it in here because I couldn't find it. So why not so evil? Solr, or search engine, is not a database's enemy. It's, if anything, it's its twin. And there's a little bit of evil, or not evil, but downside, which is the complexity. It does require you to do things that, for example, up until the block joins, you'd have to denormalize your data structures, which was a reasonable amount of effort. So we make the copy of the source of truth data available just about anywhere you want it. And redirect queries through our libraries. We make it redirect the search queries. Anything that is not a key value fetch, anything that is more than one item, we send them to the search query. Because that particular fetch for the search engine is a piece of cake. It's really because we know search engines, how they work. And this helps reduce the demand for scarce database resources. Database indexing is reduced. Database connections are much less required. And database doesn't have to use large amounts of memory doing in-memory joins. So adding search to the infrastructure adds complexity, and it comes at a cost. But done right, the benefits outweigh the costs a whole lot. So our approach. We abstract the complexity of managing the multiple pieces in the architecture. Source of truth database, cache coherence, because when you put a cache, you have to keep, and this cache is immediately consistent, so you have to keep the cache and the database in sync, so you have to write a whole bunch of code to do cache coherence. We have abstracted that out. Search queries. There's a message bus. I'll show you in a little bit. We abstract the connection pool management. And then we provide a scalable way to query across shards. But whenever you put in a distributed database or the sharded database or distributed database, immediately the problem becomes apparent. How do I do query across the whole collection or the corpus of your objects? And sending a query across to all shards is plain not good. It defeats the purpose of doing sharding, because you're supposed to go to one shard and get your data, get out of there. If you send a bad query to all the shards, what it's going to do is bring down everything at once. Not a good thing at all. And of course, I almost forgot about the analytics use case, but no, they're very big use case. But we don't want them on the OLTP databases. We take that data out and put them into the big data systems so that they do not affect the real-time OLTP data stores. So remember this situation we ended up at. This can be alleviated by this. We still have a monolithic database, but the database is much happier. We have that dark blue thing and sitting under those servers. That's our library that actually manages the writing of the data to the monolithic database and the message bus. And then any message bus. I wrote Kafka over there, but it's Kafka. It could be any open source message bus, GMS message queue. That carries your data over not only to these eventually consistent data stores, but also they can be across to different data center. So that pipe is very important. So you send the data over to Solr, you send the data over to Hadoop, and obviously we know that message bus doesn't directly write to any data store. There's the piece sitting in between, which could be custom code reading from Kafka or something like Storm with a Kafka spout, writing it out to the data stores. And number of target data stores could be any number. This is another way of doing it. The overall architecture has a lot of things, but you don't have to put everything in there. You can just have Solr and a distributed database connected via message bus. And this is the entire ecosystem that can be added onto. So you have your sharded database, you have your cache, and you have your data going. Those two things, the cache and database, are immediately consistent. Then the message bus goes through, the data goes to the message bus and goes to Solr, which is near real time, not immediately consistent. And that's where we can send all of those 70 to 80% of our use cases, or it could be higher in your business or lower, but it still takes away a whole lot of load from the database. There are no joins, like we know, and this single document, fetch the whole thing, fetch multiple documents at one shot, one network trip, and all the data that goes up to Hadoop can be analyzed with Pig, Hive, Spark jobs, your own favorite language MapReduce jobs. So you're free to do whatever you wish to do. And then another thing that can happen right from there, Hadoop, is when you create your data models, your recommendation systems or your reports, they can be pulled directly out to another system for consumption by a real-time system. So you can pull your recommendation models from there, and then you can pretty much complete the loop of feedback and serving. This is a result: scatter gather versus powered by Apache Solr. The graph before that point is scatter gather. We go to many resources, accumulate all the information, and present it to a page. And what you see is the overall response time is always going to be slower than the slowest resource tier. Slower than and then so based on which resource tier is slow and how slow it is, you'll get a very choppy response time. It's unpredictable. Maybe one of the data stores, database, or whatever store is behind it, is busy loading a lot of data. It could be the indexers indexing something, or a database doing a lot of writes and it's slow, or it's been killed by some analytics query. So then we turned on the switch to just go to Solr, fetch all the documents at this one time, return the results. Users did not experience a single change in the front end because it was all under the covers. It was the same use case being served, and the line is smooth, and it's about 1/3 of what response time we were getting before. And this has been holiday tested last year, and it has stood the test of time and pressure and traffic. Well, the lessons we learned are that a search engine like Apache Solr is not limited to search-based business applications only. You don't have to always think of, oh, I have to present a search results page, that's why I need to use a search engine. It doesn't have to be that way. When you say, when I first talked to my boss about we need a search engine, said we don't have a search page. Why do we need that? Then this is the case. So you don't always have to think about a search engine as all of the use cases that I mentioned in the first slide. It is a first-class citizen in your persistence technology stack if you want to scale. It does definitely complement the source of truth database. And it is easy to adopt because it has all of us as a community for support. The future, in our eyes, it's a symbiotic existence of Solr, Lucene with RDBMS, NoSQL, and big data systems. See, that's the future. The technology names might change in a further future, but for now, this totally works for us. It'll work for anybody who wants to use it. And with that, I will thank you all for listening to me, and you can reach me at the following URLs and email address. And Jason Sardina, who's our lead persistence architect, you can also email him. And we are hiring. Thank you.